Hello everyone, today I will show you how to make a HypsoBAR, starting from the import of an STL file with the HypsoCAD software. We have to select a new job and we need to write the patient's name. In this case, we are going to work with a removable gum, so we will select a first icon, the prepared model. After that, we have to design a bridge that goes from 46 to 36. So with the right mouse button, we select the type of job we want to do. In this case, it will be an implant prosthesis. And with the left mouse button, we select where the bridge ends. It is very important to identify the number of implants. So with the right mouse button, we put an implant in the 46 position, in the 44, in the 42, in the 32, and finally in the 34. We do not have an antagonist. We select the material with which we want to realize the prosthesis. We have a removable gingiva, so we select it. But it is very important to use the acquired wax-up function if we want to import a steel file to create a HypsoBAR. We confirm and go directly to the CAD phase. HypsoCAD will automatically open a folder where in the upper left there will be the correct file to load. The software will ask us to load the lower arch, so we load it, then the scan bodies, wax up, and finally the removable gingiva. In the preparation phase, we are going to align the scan bodies. In this case, all scan bodies are Inditex scan bodies. So first we need to select the implant position. After that, the family Inditech. The type, in this case, Nobel, Brainomark, MUA, and finally the diameter. The software will place a virtual scan body in the lower part of the desktop on which there are 3 points. We will have to align these 3 points on the scan bodies. In position 34, let's align the scan body. The software will show us the distance of the alignment. But if we want to activate an additional function to verify the perfect alignment, we can activate the color map. Let's do this operation on all the scan bodies. It is possible to change the points of the scan bodies. To be able to align them on a second face, as in this case. We automatically confirm the position of the scan bodies and the reference analogs. We can move on in the margin line phase. In this step, we have the possibility to draw the emergency profile if we want to detect the perfect contact of the gingiva. Or with the lower edit function, we have the possibility to modify the emergency profile with the control lines. With Ctrl and the left key, you can change the height of the contour lines. With Alt key and left mouse button, we can modify the diameter. We can confirm and we can move on in the external phase. In the external phase, the software will make a clone of our wax-up, so it will perfectly copy the steel file that we imported. And in this phase, we will have the possibility to model the wax-up. Or with the correct shape function, we can cut all the pre-contacts with the antagonist. Here it is. The software perfectly creates the duplicate of the wax-up. We can obviously go to add, remove, or deform the material of our prosthesis, as in this case. Or we can cut all the pre-contacts with the correct shape function. Otherwise, we can go ahead. In the frameworks phase, the software will reduce our prosthesis. From the settings tool, we can reset this parameter to be able to return to the anatomic shape. After that, we go ahead in the refinement phase. In the refinement phase, the software will connect all the implants to the prosthesis. It will create the screw channels, and with the HypsoBAR function, we will create the bar inside the prosthesis. We need to draw a contour line in the lower part of the prosthesis, and automatically HypsoCAD will create the HypsoBAR. Obviously, we can also interact with different functions, such as changing the screw channel to create an angled screw channel, and the software shows us the degree of inclination of our channel. Or we can use the hole protection function if we want to modify the screw channel protection. Or, as we said, we have the possibility to go and draw the perimeter of our HypsoBAR. It is very important not to select the perimeter inside the implants. And when we finish, we select a yellow dot. Automatically, the software creates the HypsoBAR within the prosthesis. And we can modify this HypsoBAR through parameters. For example, if we want to create a support for the secondary prosthesis, we can increase the chamfer. We can angle this chamfer. And of course, we can modify the angle of our bar if we want the upper smoothness. Or we can modify this bar through a plan. By activating the plan function, you can modify the height, the direction, and the inclination. Once all these steps are completed, we have the possibility to modify the offset, so the cementing space or the minimum thickness of our prosthesis. A very interesting function we have in the software is the possibility to create a morphological bar and not a flat one. All we have to do is taking the flat bar function, and we can manage this bar through the height parameter. In this case, we want to create a flat bar, so we activate this filter. Then we can proceed. Automatically, the software creates the bar inside the prosthesis. I deliberately placed this bar outside the prosthesis to show you a new function we implemented in HypsoCAD. The Adjust HypsoBAR function. Because if we want to use this function, we can simply press apply, and automatically the software will put the HypsoBAR inside the prosthesis. After this, you have the possibility to modify the prostheses and, of course, the bar, simply by adding and removing material on the prostheses. Or by selecting HypsoBAR, I can go to modify the HypsoBAR, obviously with the same parameters, or with the deform function. If we want to see the thickness of the prosthesis, we can activate the color map. The software will automatically show us the thickness of our prosthesis in a specific point, as in this case. We do not have to worry about the minimum thicknesses, because the software can automatically restore them in this transition phase. At the end, the software will create 3 different STL files. The first file for the upper prosthesis, the second file for the bar, and a file for the complete prosthesis without subtraction. Because if we want to print this file as proof, we can do it to check the vertical dimension before making the final ones. The software creates the upper prosthesis, the lower prosthesis. And the prosthesis without subtraction. As you can see, if we do not respect the minimum thickness, the software will automatically do it for us. With this function, we can choose the export path. Or we can go ahead without selecting anything, and the software will export our file inside the design folder. Inside the CAM folder, there will be the 3 STL files with their metadata.